Hello everyone, I'm going to talk about the calculation of half-life. In order to understand this video, you need to know how half-life works, you need to know exponential functions, and logarithmic functions. Okay, first of all, we have the formula. This formula is the formula for calculating the quantity after time t. N1 is the quantity of a substance after time t, and N0 is the initial amount, which is the initial quantity, and we have coefficient 1/2. In the exponent, we have t over t1/2. T is the time period, and t1/2 is the half-life. Then we can see here's the graph. This is the first half-life. We can see the N1, which is the quantity after time t, is half of the initial quantity. And then this is a graph of exponential decay. Okay, now what if we know the quantity after time t, but what if we want to get the time t? Okay, now this is how we convert this formula into another formula. First of all, we want to remove n0 on the right side. So n1 over n0 equals this. Okay, now we want to get t. So this is an exponential function, and we can rewrite it into another form of logarithmic function. So we have we have this, and then we can rewrite it into this form. And then we want to separate those two, and according to the rule of logarithmic subtraction, we can separate that expression into this. Okay, now we're very close to our goal. Now we need to remove this, so we can time both sides by t1/2. Now, here is our final equation for finding the t with the given quantity after time t. Okay, now let's quickly go through the examples. Those two examples, we can go through them quickly because they're just substituting the formulas, the two formulas. Okay, now the first one, we have carbon-14 has a half-life of 6,000 years. There was 30 kilograms carbon-14 initially. How much carbon-14 would be left after 16,000 years? Okay, we have 16,000 years. This is our t. 6,000 years. This is the half-life. So this is a t1/2. 30 kilogram. This is the initial amount of carbon-14. So we have n0. And we want to find n1. So by the formula, we have n1 equals to n0 times 1/2. Then 16,000 over 6,000. This is about 4.72. Here, what is the unit? Okay, remember, this unit, n1, the unit of n1 is always equal to the unit of n0, because we want to keep all the units to be the same. So, kg. Okay, on the second example, we have carbon-14 has a half-life of 6,000 years. If there was 30 kilograms carbon-14 initially, after how many years will there be 4.72 kilograms of carbon-14 left? Okay, now we have 6,000 years. This is our half-life. So again, and this initial amount. At this time, we know this n1 already, and we want to find the time, which is the t. So just substitute. We have and this is about okay, this is about 16,000 8.42 years. And how do we get the unit? Again, we want to keep the unit same as other the other t1/2. So we have here, this is years, so this is also in years.